about a very exciting topic. Here, like we've done in our previous video, we've been able to just say something about sound, but today we're going to be expanding it more. So we know that sound is produced by a vibrating body, and sound wave sound waves are what longitudinal waves, and also they require the medium of transmission. That means they need a medium to be transmitted from one point to another. Unlike what we have in a electromagnetic waves that does not need any medium of transmission. A good example of that is radiation. Does not need any medium. It moves in a vacuum. Unlike that, sound waves are not like that. Sound wave sound waves are produced they are formed as a result of compression and refraction of the medium of transmission. The compression and refraction of this medium produce the wave of sound. Being a longitudinal wave, being a longitudinal wave, the direction of transmission of the wave and the um, the direction of the transmission of wave and the molecular particles they move in a parallel direction. They are all parallel to each other. Their movements they are all parallel in each other. So in this case now, there's a very important phenomenon that always occur in sounds. That is the resonance. Resonance is said to occur. It occurs when a given body is set into vibration. Is set into vibration by its own natural frequency at its own natural frequency. Set into vibration at its own natural frequency um, due to the impulse received from another body which is vibrating with the same frequency. So when this thing happens, you will hear a very loud tone. And we all normally do this experiments, resonance tube experiment with what we call acoustical resonance. So in acoustical, this resonance tube, this resonance tube is designed in such a way that it has a tap. It has a tap where water is released. So the more you use your tuning fork and place at the top of it, once the vibration of the tuning fork will set the air column here into vibration. Once the loud sound is heard, or the tone, the first tone is you will receive the first resonance. That means the first resonance has occurred. At this point, it means that at this point the length is equal to lambda over 4 is equal to lambda over 4. That is to say, that is lambda stands for the wavelength. That is to say, the wavelength now is equal to 4L. That will give us the wavelength. So being like that, we also know that the velocity of sound is the frequency over wavelength. Then to calculate the frequency, we have it to be velocity over lambda. That is how we got this. This is standing for the first frequency. That's the fundamental frequency of the resonance experiment or resonance tube or closed pipe. So in most cases, when we're using this our resonance, we always consider what we call the end correction. The end correction, when the end correction is considered, we can use a formula like this in order to compensate, for the gap between the tube and the tuning fork. There's always a small gap here between them. Then that is what we call the end correction. So in this case, we've been able to look at this. What we're going to look at again, we're going to look at some calculations that will help us really understand how to do some of these calculations. Let's look at, I'm going to take some simple calculations that will guide us effectively. So the first question we are going to look at, the question says that a pipe closed at one end is 60 cm. The air in the pipe is set into vibration and the fundamental note is produced. If the velocity of sound in air is 360 meters per second, calculate the frequency of the note. So based on that, since it's the first the first node, which means if you are going to make a drawing of it, it looks like this. This is the air or the water, and then this is the air column. At this place we have the nodes, and then this is the antinode, and then we have the length, which is equal to lambda over wavelength over 4, and this is a picture of what they said, that this the closed pipe one end this place to that place is what 90 cm. It's 90 cm. Since it's 90 cm, it's certain as 0.19 meter. 0.9 meter. Now the first thing we're going to do here is to get the value of the wavelength. Now the wavelength, since the wavelength is known to be wavelength, the length of the closed pipe is over 4. The wavelength, the length is this, equal to wavelength over what? 4. Therefore, crossing over, we have wavelength to be equal to 4 times 0.9. That will give us 3.6 meter. That is the wavelength. So we said that we should calculate the frequency. We know that the frequency and the wave, the velocity or the speed of sound in air, we can calculate it with this formula, where the F stands for the frequency, this lambda stands for the wavelength, and this is the velocity. So now what we do, can make, since we're looking for the frequency, we can make the frequency the subject of the formula, which will look like this. So being that we have the lambda to be 3.5, and the velocity is what? Our lambda is 3.6 meter. So we can then go for the frequency over 4. That will give us the frequency now will be equal to 100 hertz. 100 hertz. That is the value of the frequency. So the next one we're going to look at now, we're going to try another question, and as you're watching this, I would like you to drop your comments on the comment section, so that I can always relate with you. That's one of the ways I communicate with my audience. All right, let's look at the next question we're going to see here. All right, the next question is what we have here. The question says, in a resonance tube experiment, as shown, this is the experiment. We have a tuning fork there, we have the tube, the closed pipe there, and then the frequency of the tuning fork is what? 850 hertz, and the resonating length of air column is 0.7 meter. Calculate the velocity of the wave. So in this case, we're going to do, if you look at that very well, we find out that this seems to be the second resonance. At the second resonance, since the first one we have to be 4 over lambda, that is the second one. Adding up this one we have here, we have it to be lambda over 2. That is 4 here. Here we have plus this times, there we have lambda, we have it 3 lambda over 4. Now this is the second, that is what we have at the second resonance. The second resonance, we have this to be our what? Equal to the length. In that case, all of them, if we have it to be like this, the length is equal to, that is what we have. So um, the next thing we are going to do here is to substitute the various values that we have. If we are substituting the various values, so we know that length is equal to, and then the lambda crossing over, we have 3 equal to 4L. Then the wavelength will then be 4 times L over what? 3. 4 times L over 3. Now we know that our, okay, the air column is 0.7. Then we have 4 times 0.7 over 3. That will give us 0.9 meter. 0.9 meter. Now we said that we should calculate the velocity of the wave. If we are calculating the velocity of the wave, so what we do, remember, we know that velocity is always frequency over what? Wavelength. Then the frequency here is times wavelength, which is, so what we have here will then be, the final answer will be 793 meter per second. That is the wavelength, the velocity of the wave in question. So this is the final answer to that. All right, thank you so much for being part of the class. And like I said, the comment section is very important so that you can drop your comments and any question you think you can ask. And then that's one of the ways I communicate. And then if you have not subscribed, you should try and make sure you subscribe. You can also go to our description section where you can get our Facebook page, the link to our Facebook page, and we can also communicate from there. Thank you so much.